Hello and welcome to today's video. So on the workbench today we have the Solectria brushed DC motor controller, and yeah, it looks like it's all working now. So if you watched the last video, I'd swapped out some chips and logic level chips that were bad, and those were all working, but we still had problems with the switch mode power supply. It wouldn't self start. I had to jump start with the power supply every time because its internal voltage regulator was bad. So, thinking it would be really simple, I put a new switch mode power converter chip in, and I should have recorded a video because when I applied power, lots of smoke came out. It blew up. It also killed the switch mode MOSFET that runs the primary of the transformer and the 1 ohm current sense resistor. They all smoked, lots of smoke. So, they've all been replaced. So, you can see I've got a new MOSFET in there, and that is actually, because the spacing is for one of the bigger TO, 37 package, instead of like a TO 220. Yeah, I think it's a TO 237 package, the bigger one. This is actually a MOSFET from that I use to repair the AMC motor controllers. So it's like one of the 8 that's in each phase. So a little overkill, but yeah, it'll get the job done. And then I looked everywhere. I could not find a 1 ohm resistor. So we have, I don't know if you can see in there, but that one's a 0.47 ohm. And I have a 0.56 ohm resistor in series because I didn't have a, I have quarter watt, but it needs to be at least a half watt resistor for that. And that is for the startup supply. Or no, that's for the current sense. It's a 1 ohm current sense resistor. And yeah, so the only other thing I changed with this was this capacitor right here, because I think that was the whole problem. That was a 1 microfarad tantalum that is a dead short, and I think that's what killed it. Now, I don't know how it was working with me jump starting it, because if this guy was shorted, it shouldn't have worked. So I'm thinking we were on the hairy edge of it just being like a really bad resistor, and that finally let go when I put the new chip in. Or, I don't know. It doesn't quite make 100% make sense. It's also possible that the replacement chip that I put in was also bad, and it just blew up the supply, and then killed that tantalum as well. So let me show you where that is. So I don't have the schematic for the switch mode power supply, but let's turn off the. There we go. This is the schematic for the chip, for the TSC 9110 chip. And they use this exact schematic. Essentially, this is the exact thing. The only difference is this would be your 36 volts in instead of ground, and rather than minus 48 volts, that would be your ground here. So ground and 36. They even have that inductor in there, but they have it on the other side. But everything looks exactly the same, except this is like a 100 microfarad capacitor instead of a 20, but everything else is identical. So none of this section's populated. So that 1 microfarad capacitor is actually right here. And that's exactly where it's at. And so if that was shorted, we lose our 10 volt supply, which goes to pin 6 here, which powers the chip. But it also takes out feedback on pin 14 because it would short that to ground as well. Well, it would essentially make it, yeah, it wouldn't work very well. So if we were to go to the other page here, and the internal block diagram of the, well, actually it's pretty much a schematic of the inside of the chip. So that 36 volts is coming in here. It goes through this pass transistor. This is internal to the chip. This section was dead in the other chip. So we got 8.6 volts here for this comparator, which is driving this guy. So that's going to make this be around 8.6 volts. And if you see, that's what goes back out pin 6 to power itself, to get everything up and running. And once it's up and running, you switch over. So this will generate your 8.6 volts here. So that was essentially shorted to ground through that tantalum. That was bad. So essentially you get your 8 volts here. If this guy starts up, it starts switching this. This is that MOSFET that died. And then this is the 1 ohm current sense resistor here. And so this starts switching, you start building up some power, and then eventually this starts up, and then you get 10 volts here. In this case, it's 15, which they're regulating down to 12, so there's like a linear regulator out here, and that comes back over and feeds the chip that way. So you don't have to run that internal supply. Once it's above that 8.6 volts, it shuts off. And that wasn't working. So it couldn't self-start, but I'm not quite sure like how it would have worked unless that 1 microfarad tantalum was just on the hairy edge of not functioning. Like it was just acting like a resistor and wasn't, maybe we had a bunch of spikes. But it starts to make sense. If that was going bad, we lose our feedback, which causes this output to go haywire. It goes really high voltage, which then allowed high voltage or maybe even spikes to get back through and kill all the other chips. So I think that's the failure mode. I think it can be tracked down to this tantalum was just going bad or was bad, but it's definitely shorted now. So yeah, like I said, I replaced it. I got a new, what was it, 91110 switch mode chip in there, new MOSFET, new 1 ohm resistor, current sense resistor. Everything else is the same, all new chips. These are all the ones that were bad that I took out. And yeah, those are the screws for the cover. But yeah, I'll go ahead and show you working here. So now, notice no wires over here, so we don't need to jump start it. I could just flip it on now. And green LED came on. We're good. So she's up and running already. So I can just go ahead and get everything in the frame, give it a little acceleration, and she spins. So I can back it down. So I emailed the customer about the operation, and he says that he believes that this is correct. You are actually commanding a current with the pot, and it is measuring with the current sensor and comparing the two and feeding it. So I obviously, at this point, I'm commanding about 230 milliamps, and that's what it's putting out because that's what the motor's doing. So yeah, it looks like it's all working. I think we're good. Anyways, it was quite a bit longer than I expected for the video, but I think that's a good explanation of what went wrong. And I think I have the failure mode, because I always like to know what actually caused the original problem, and I think that it was this guy, this capacitor going bad, caused all kinds of problems. Maybe it was an open circuit for a while, and then it became a short. I don't know. I know that sometimes these tantalums, they'll start acting like resistors for a little bit, and maybe it just finally died. But yeah, that was it. I replaced it with an electrolytic because I didn't have a tantalum to replace it with. But yeah, good. Anyways, thanks for watching. Oh, let me turn this off. Thanks for watching. Bye.